in LIC third unit. The second module of the third unit is sample and hold circuit as well as DAC. Sample and hold circuit is an important analog building block with many applications, which includes ADC as well as fixed capacitor filters. The function of sample and hold circuit is to sample an analog input signal and hold this value over a certain length of time for subsequent processing. Simple sample and hold circuits using MOS technology is represented in this diagram. Alternative CMOS sample and hold circuit is represented in this diagram, which does the series sampling. Switched op-amp based sample and hold circuit is represented in this diagram. The sample and hold circuit can be constructed using only one MOS transistor and one hold capacitor. The functional diagram of LF398 IC is represented in this diagram. The connection diagram is represented in the diagram. Next topic is ADC, analog to digital conversion. The real-time signals, available signals, are analog in nature, but if we want to process the data by means of processor, or if we want to store the data, means we have to convert the analog data into digital. There are varieties of analog to digital converters are available. First one is direct conversion ADC or flash type ADC. As per the name itself, this is the fastest ADC, which is very fast with a sampling rate of up to 1 GHz. The resolution is limited because of large number of comparators and reference voltages are needed. Here, 2 to the power of n-1 comparators are used to convert the analog data into the digital data. Here the limitation is if number of bits or increases, means if suppose n is the number of bit, means we need 2 to the power of n-1 number of comparator. So the cost of the converter as well as the complexity of the converter is very high. The second one is successive approximation ADC. This is based on successive approximation register. This is also called bit weighting conversion, that employs a comparator to weight the applied input voltage against the output of an DAC. Successive approximation ADC is the mostly used converter because of its faster range as well as its medium cost. The next one is integrating type of ADC. Here the current proportional to input voltage, which charges a capacitor for a fixed time interval. At the end of this interval, the device resets its counter and applies an opposite polarity negative reference voltage to the integrator. This diagram represents the integrated type ADC. Next one is sigma delta ADC or oversampling converter. It consists of two main parts, modulator as well as digital filter. Modulator includes an integrator and a comparator with a feedback loop and one bit DAC. A sigma delta ADC, which is also called as delta sigma ADC. oversamples the desired signal by large factor and filters the desired signal band. Analog to digital converter using voltage to time conversion. The block diagram for the voltage to time conversion is represented in this diagram.